Welcome to apengineershub design mix of concrete. Example on concrete mix proportioning for M40 grade concrete. Stipulations for proportioning. Grade designation M40, type of cement OPC 43 grade. Maximum nominal size of aggregate 20 mm. Minimum cement content 320 kg per cubic meter. Water cement ratio 0.45. Workability 100 mm slump. Exposure condition severe. Method of concrete placing is pumping. Degree of supervision good. Type of aggregate crushed angular aggregate. Maximum cement content 450 kg per cubic meter. Chemical admixture type super plastizer. Test data for materials. Cement used OPC 43 grade. Specific gravity of cement 3.15. Chemical admixture super plastizer. Coarse aggregate specific gravity is 2.74. Fine aggregate 2.74. Water absorption coarse aggregate 0.5%. Fine aggregate 1%. Target strength for mix proportioning. F dash Ck is equal to FCK plus 1.65 S, where F dash Ck is equal to target average compressive strength at 28 days, FCK is equal to characteristic compressive strength at 28 days, and S is equal to standard deviation. From table 1, standard deviation, S is equal to 5 Newton per mm square. This is 5 Newton per mm square for M40 grade. Therefore, target strength is 40 plus 1.65 into 5 is equal to 48.25 Newton per mm square. Selection of water cement ratio. From table 5 of IS 456, maximum water cement ratio is equal to 0.45. Based on experience, adopt water cement ratio as 0.4. 0.4 is less than 0.4, hence OK. 0.45. For severe condition. Selection of water content. From table 2, maximum water content is 186 liters. That is 186 for 20 mm size aggregate. Estimated water content for 100 mm slump is equal to 186 plus 6 by 100 into 186 is equal to 197 liters. As superplaster is used, the water content can be reduced up to 20% and above. Based on trials with superplaster, water content reduction of 29% has been achieved. Hence, the arrived water content is equal to 197 into 0.71 is equal to 140 liter. Because 100 minus 29 is equal to 71. Calculation of cement content. Water cement ratio is equal to 0.4. Cement content is equal to 140 by 0.4 is equal to 350 kg per meter cube. From table 5 of IS 456, minimum cement content for severe exposure condition is equal to 320 kg per cubic meter. 350 kg per cubic meter is more than 320 kg per cubic meter, hence OK. Proportion of volume of coarse aggregate and fine aggregate content. From table 3, volume of coarse aggregates corresponding to 20 mm size aggregate and fine aggregate zone 1 for water cement ratio is of 0.5 is equal to 0.6. This is 0.6. In the present case, water cement ratio is 0.4. Therefore, volume of coarse aggregate is required to be increased to decrease the fine aggregate content. As the water cement ratio is lower by 0.1, the proportion of volume of coarse aggregate is increased to 0.02 at the rate of plus or minus 0.01 for every plus or minus 0.05 change in water cement ratio. Therefore, corrected proportion of volume of coarse aggregate for the water cement ratio of 0.4 is equal to 0.62. Note: in case the coarse aggregate is not angular one, then also volume of coarse aggregate may be required to be increased suitably based on experience. For pumpable concrete, these values should be reduced by 10%. Therefore, volume of coarse aggregate is equal to 0.6 into 0.9 is equal to 0.56. Volume of fine aggregate content is equal to 1 minus 0.56 is equal to 0.44. Mixed calculations. The mixed calculations per unit volume of concrete shall be as follows. Volume of concrete is equal to 1 cubic meter. Volume of cement is equal to mass of cement divided by specific gravity of cement into 1 by 1000. 350 kg divided by 1000 divided by 3.15 equal to 0.111 cubic meter. Volume of water is equal to mass of water divided by specific gravity of water into 1 by 1000 equal to 0.14 cubic meter. Volume of chemical admixture superplastic is at 2% by mass of cementous material is equal to mass of chemical admixture divided by specific gravity of admixture into 1 by 1000 is equal to 0.06 cubic meter. Volume of all in aggregate is equal to A minus B plus C plus D, that is volume of concrete minus cement minus water minus admixture equal to 0.743 cubic meter. The balance. Mass of coarse aggregate is equal to E into volume of coarse aggregate into basic gravity of coarse aggregate into 1000 is equal to 1140 kg. Mass of fine aggregate is equal to E volume of all in aggregate into volume of fine aggregate into basic gravity of fine aggregate into 1000 equal to 896 kg. Mixed proportion for trial number 1. Cement 350 kg per cubic meter, water 140 kg per cubic meter, fine aggregate 896 kg per cubic meter, coarse aggregate is equal to 1140 kg per cubic meter, chemical admixture 7 kg per cubic meter, and water cement ratio is equal to 0.4. Aggregate should be used in saturated surface dry condition. If otherwise, when computing the requirement of mixing water, allowance shall be made for the free surface moisture contributed by the fine and coarse aggregates. On the other hand, if the aggregates are dry, the amount of mixing water should be increased by an amount equal to the moisture likely to be absorbed by the aggregates. Necessary adjustments are also required to be made in mass of aggregates. The surface water and percent water absorption of aggregates shall be determined according to AS 2386. The sum shall be measured and the water content and dosage of admixture shall be adjusted for achieving the required slump based on trial if required. The mixed proportion shall be reworked for the actual water content and checked for durability requirements. 2 more trials showing variation of less or minus 10% of water cement ratio in step number 10 shall be carried out, and a graph between 3 water cement ratios and their corresponding strengths shall be plotted to work out the mixed proportion for the given target strength for field trials. However, durability requirements shall be met. Thank you.